Good morning. This is going to be a follow-up on the video I did last week to show how to build a color profile from an output color profile from color measurements. As you may remember, this is what the color profile measurement target looks like. This is a series of RGB images. If I can only activate the RGB here, read out, and using the color picker, you can see that at this point here I have 0, 0 RGB, and at this point I have the maximum of RGB, which is 255. And I bet it's followed up by a green scale from up, not quite 0 green in this case, up to 255. Could be that the 0 or 20 green is hidden somewhere else, maybe combined, because after all this has 0 green, so why duplicate another 0 green color? And how about this? Same thing with the blue, you see. So these three scales, red, green, and blue, they comprise the main primary scales. This is what all the other colors here are supposed to be derived from. There's white, which would be the paper color, which is right here. And then there's a bunch of grays. Grays that are made of equal RGB content, like this patch for instance, but there could be grays that are not made from equal RGB contents, like this one, to test or to characterize or reveal the behavior of the grays inside the device. The rest are combinations of colors of various red, green, and blue, and the top here is just a series of reference patches. They're all black, and same at the bottom. I bet you already figured that out. So this comprise all these 200 and I think it's 80 sample colors. This comprises all the colors that are supposed to sample the color space of the device. Now let's go and turn to a utility called Chromic Colored Ink, and let's see if we can figure or help our understanding with this tool. So I'm going to open this part of the software called 3D Graph. Open 3D Graph. So when I open the 3D graph, there's a blank window that appears like that, and in the list here it's empty. So I'm going to click the plus button, and here's the open command, and now this brings me over to my desktop, and I'm looking for something that's called tc283rgb.tif. It just won't open any image file, but it will open a lot, and also some files, some text files that only have some numbers in it. So let's open this file and see what we can learn from ColorThink. Okay, the file is being opened, and here's the beauty. This is how the files, actually the colors that we propose to sample ourselves, look like when we look at it in a 3D space. You can see an interesting phenomenon is that there's the three primary colors, the blue. So where's the blue exactly? The blue starts from here. This is the most saturated blue, and this is the white. This is the paper. So there must be patches of color that are spread out along this dimension from white, paper white, to maximum blue, and must be the same thing over for red. Here's the maximum red, and here's the paper white again for reference. So we must have somewhere a continuum of RGB colors that are distributed over this dimension to characterize the red, and same thing with the green. See the green at the bottom, green here, and then there's a series of green, progressively less saturated green patches from saturated green to white. So that forms the three sort of arms of any color profile or any color space. So what's interesting also to note is that once there's green, look where the yellow lies. The yellow lies exactly smack between the red and the green. If you were to draw RGB additive synthesis graphs, this is what you would find. That yellow is made out of red and green. Same thing if we unite the green and the blue, we find cyan in between. And same thing if we unite blue and red, we find magenta on this axis, you see? So this is very, very logical, and since it's so logical, I call it intuitive. Now, what's not really intuitive over here is that where we're witnessing is really the form of a cube, but a hell of a compressed and distorted cube. If you can picture this, this is one side of the cube. This is another side of the cube. It doesn't look straight at all, but what can I say? Same thing over here. It's another vertex of the cube, and this is another vertex of a cube. Looks like a square. This is the square, and then there are other squares, and together they comprise and they make a cube figure in three dimension. Now at the middle, I'm sure as I rotate the graph, you can see all these grays. Look at the number of grays that are in between. This is the gray axis. So as you can see, out of the total number of patches or measurements that the software spends a lot of color or samples or measurements, a lot of the total sampling just to sample grays, so that the profile should be able to get grays correctly. Now, what you can argue is that, see this area? It's empty. There's no samples here. So predictions of the color profile might be not as, right or correct over here. Same thing over here for this yellow area, and same thing over here for this sort of blue area. Look, there's no samples. So that's not, I wouldn't call it imperfection, but that's the result of not sampling colors, enough. This is an RGB, sort of measurement chart. There could be RGB measurement charts with a higher number of colors, but and they would do a better job of sampling the color space than just these 280 colors. Let's see if I can find one quickly. Let's see what's on favorite. Let's see Adobe RGB. Yes, if I can open Adobe RGB. Problem is that Adobe RGB doesn't have samples, color samples inside it. So I'm going to try to bring down the opacity so you can see the relationship between Adobe RGB and the inside here, which is what? Which is my printer, my Epson printer profile. So you could say that, there's a relationship between the two, but in terms of greens, look how far out the greens of the Adobe RGB go. The most saturated greens compared to my printer, my Epson printer green. This is a very interesting analysis. Let's see if I can bring up an image. And let me open this. I have in my libraries, pictures, sure I have a ton of images over here. Let's see if I can, how about this image here, which is in ECI RGB. Let's stick with RGB image. So this is the one I'm opening up right now. Is it coming up or the program doesn't want to open it? So sometimes the program, this disappoints a little bit. I don't see a reason why the program could not have displayed this image. Let's try another one. Sometimes the program will refuse to display them, and nothing I can do. About this accordion picture, let's see if I'm lucky. This time it opens it up. So here's my accordion picture opening it up. I have to be patient. I hope the program has not crashed. So let's hide my Epson. These are the accordion picture colors. You see there's some reds, there's some blues, there's some sort of skin tones, and sort of very low saturated tones over here. So I like this program. It's really useful to characterize or to study. It's worth having. I like having it. So this is again they're supposed to show my, maybe because I'm having difficulty here selecting. Oops, I'm so afraid at point I'm gonna lose out the program. You see, so now I have my Epson sort of color range, and I can see that the accordion tones fits inside this color range quite well. Now the only thing I could ever want more is maybe improve the quality of my profile, but it's worth giving it a try in this form. I'll come back in later videos with other data sets, samples, to show you how more extensive they can sample colors inside some color space. Thank you for watching.